Question 12, Part B. A particle is moving along the x-axis in simple harmonic motion. The position of the particle is given by x equals root 2 cos 3t plus root 6 sin 3t for t greater than or equal to 0. Part 1. Write x in the form r cos 3t minus alpha, where r is greater than 0 and alpha is greater than 0 and less than pi over 2. The displacement equation is given by x equals root 2 cos 3t plus root 6 sin 3t. We'll call this equation number 1. Note the coefficients of cos 3t and sin 3t. The coefficient of cos 3t is root 2. The coefficient of sin 3t is root 6. Now to get the value of the amplitude r, we square the coefficients, add them together, and then take the square root of that sum. So the square root of root 2 squared plus root 6 squared is equal to the square root of 8, or 2 root 2 when expressed in simple surd form. Now recall the trigonometric identity r cos 3t minus alpha is identical to r cos alpha cos 3t plus r sin alpha sin 3t. Now we're going to equate this term here, the r cos alpha cos 3t, with this term here from equation number 1, since both of those have a cos 3t term in it. So in other words, r cos alpha is equal to the square root of 2. And this will allow us to find the value of alpha. So we can set this up as an identity. Root 2 cos 3t, so that's this term here, is identical to this term here. Now we know the value of r. It's the square root of 8, or 2 root 2, cos alpha cos 3t. So the coefficient of cos 3t on the left-hand side and the right-hand side are the same. So root 8 cos alpha is equal to root 2. And I've written that here. Now dividing both sides by the square root of 8, we get half. So cos of alpha is equal to half. Hence, alpha is equal to pi over 3. Now that we have the value of r and alpha, we can express x in the form r cos 3t minus alpha. Therefore, x is equal to 2 root 2 cos 3t minus pi over 3. Part 2. Find the two values for x where the particle comes to rest. The particle comes to rest when it is furthest away from the origin. Whether it is to the right-hand side or to the left-hand side of the origin, when the particle reaches the maximum extent or the maximum distance it can go, that's when the velocity is 0, and that's when it changes direction and then goes back the other way. And that occurs at a distance that is equal to the amplitude of the function that we found in part 1, using the r cos 3t minus alpha form. Now we've found the value of r, which is the amplitude of that function, which is 2 root 2. So the two positions when the particle comes to rest is x equals plus or minus r, which is plus or minus 2 root 2. Part 3. When is the first time that the speed of the particle is equal to half of its maximum speed? Recall the displacement equation that we found in part 1, which was x equals 2 root 2 cos 3t minus pi over 3. Using the chain rule, we can differentiate x with respect to t to get the velocity equation x dot. So x dot is equal to negative 6 root 2 sine 3t minus pi over 3. Now x dot will vary between negative 6 root 2 and 6 root 2 inclusive of the endpoints. So the maximum speed is this value here, which is 6 root 2. Hence, half of the maximum speed is 3 root 2. So we're going to solve for t the equation negative 6 root 2 sine 3t minus pi over 3 is equal to 3 root 2. Dividing both sides of the equation by negative 6 root 2, we get sine 3t minus pi over 3 is equal to negative half. Then taking the inverse sign of both sides, we get 3t minus pi over 3 is equal to negative pi over 6. And then adding pi over 3 to both sides, we get 3t is equal to pi over 6. And then dividing both sides by 3, we get t is equal to pi over 18.